Hello, my name is Brandon Crane from Truman State University.
And hello, my name is Ali from Akhawayn University of Morocco.
We are students in the Artificial Intelligence class here at Akhawayn.
And we will present you our program. The idea is that it will try to fool the reCAPTCHA system of detection of bots, sorry. And the idea is that given a set of pictures, like 4 pictures with a given label, it will detect which one is not corresponding to that label.
So the technologies that we're using is the TensorFlow in order to access Google's Inception v3 neural network. In order to do this, you will need a Docker installed on your system. I'm using the Docker Quick Start terminal. The first thing that you have to do is you have to start Docker with this command. You will create a virtual session that links a directory on your local machine to a virtual directory in the Docker machine. This is the image that we are using, the Docker image, that is all set up to run. It has all of the package needed to run our program.
And this image can be found in our GitHub.
So we just started Docker. We will now navigate to that directory. And we now have all of the files here that we need in order to fool reCAPTCHA. This is the Python file that we will be running, and all of our images that we will be testing and training are located here as well. So here's what it looks like in the local directory. We first have our training photos. Our program has already been trained on these labels, and what it's set up to do is when we search for a label that it doesn't have, it will crawl the web and download photos and then learn from them and then test the photos that we give it here, the test photos, against what it's learned.
So our experiment will try to detect which one of these photos is a Trump photo. So at the end, we expect that it's gonna say that the Hillary one is not Trump. We'll try to run our program now. So the first thing is that you need to run the Python program with the first argument as the label that you want to test against. The second one is the photo that you want to test against as well. So we have 4 photos in here. We will enter them, all of them, after the label as commands. You can enter as many as you want. They are all going to be considered. And at the end, as I said, it's gonna try to say that the Hillary 1.jpg is not a Trump photo. So in some sense, does not correspond to the label that we have given it.
All right, so here we go. I think I have everything correct. Let's run it.
So as you can see, it's trying to crawl the internet. So the idea is that it gets to Google Images and try to download all possible images. So let's look at what have been downloaded so far.
So we will go to the training photos, and you can see that it's created a new directory here. And this is where all of our photos are going.
And the name of the directory corresponds to the label
that you gave it. This label here.
Let's look at some pictures that we have that the crawler has automatically downloaded. And as you can see, it has downloaded from the internet a bunch of pictures corresponding to the label so that it can train on them. Our program is written so that it downloads 300 pictures right now. We will wait as it downloads all of them.
So we currently have, like Ali said, 300 queued to download. It will get somewhere around there until the threads run out. It's advised in order to train a neural network to have as many images as possible, but the more images that you have, the longer it will take to train. So there is a trade-off. One thing to keep in mind is that all of these images have to be JPEG images. So you can come through here and see that some of these are indeed not JPEG. Some of them will be ASPX or PNG, and these will not work for our system.
And so our program takes into consideration at the end of the downloads of all these pictures that it has to delete all those ones that cannot be treated as JPEG.
There are also some tricky hidden JPEGs that they actually say that they're JPEG for the extension, but they are actually PNG when you actually inspect the file. So our program also takes into account fake JPEGs. I don't know if there are any in this set, but it is necessary in order to get this to work. So we're getting pretty close. We'll just wait for a little bit longer. It's about to start training, which means that our delete script should have run. As you can see, there's no more PNGs in here.
Now TensorFlow has started its training of neural networks with Google Inception. It will go through all the pictures that we have in the term folder, and it will learn from it, and after that it will start comparing with the pictures that we will test against.
Okay, so we've let it train and the results are in. It only took about 10 or 12 minutes. So what it was doing here is it was caching files about the data that it gathered from these Trump photos. So once we have all these bottlenecks created, all this data that the neural network has gathered from these files, we don't actually need to create these bottlenecks again. So it is all in the cache now. It's all cached up. And so if we run this again, it is already trained on Trump. And so it will give us very, very quick results. So as you can see, there was about 250 bottlenecks created from just Trump, and then all of the other ones were already trained. So these are the rest of the bottlenecks that we already have on our system. So the next thing that it does is it will take 10 photos and run them through a test. It will keep readjusting its parameters until it's so that it learns more and more each step. So as you can see, the train accuracy, the cross entropy, and the validation accuracy change from run to run. And this is actually scheduled to run for about 500, I believe, 500 steps. So the training accuracy is how accurate it is against its own data, against the data that is already in this training folder right here. The validation accuracy is how accurate it is against photos that have been left out of the testing. So each one of these only tests 10 photos, so it can automatically set aside some photos that it uses for each of these. It knows which photos are being used in each step, and in the validation accuracy, it tests photos that are not being used in this step. The cross entropy is how much it is actually learning through this process. So we want this to go down. As you can see, it fluctuates quite a bit, but this is the function that displays how well it is actually learning. So now we get to the final accuracy. This should be anywhere between 85 and 100%. But this is the final test. It takes what it's learned throughout its entirety of the 500 steps and tests, again, photos that it has not tested before. So it even sets out photos for this final test. This just means that it has output 2 files that we can use to view this data.
Okay, so now we can interpret our results. We know that our neural network has already some results, has already trained itself against some other labels like dog, sunflowers, daisy, rose, and tree, and it has newly trained itself to a label called Trump. So now the first picture, which is trump4.jpg, is testing it against the label Trump, or what it has learned from the label Trump, and it has found that it has a score or a probability of 0.99, which is pretty high. So it is 99% sure that trump4.jpg is Trump. Okay, and we can do the same for other labels and other pictures. Like Trump5 is 99% sure. Trump6 is also 99 and something sure that it is Trump. And we go to the last picture, which is Hillary. How Hillary
She is very close to a Trump. But what our Python program is set to do, it takes the label and it looks at the minimum score for each photo just for the label that we want.
So the problem is that Trump and Hillary are both human beings and have the same shape, the same colors, as they both have golden hair in some sense. But if our neural network was trained before or on Hillary Clinton, it will recognize the difference between the two, but it hasn't been trained on that. So the idea is that yes, it will think at 97% that it is Trump, because first it's a human being, they have the same shape, they have the same texture and colors, but Hillary1.jpg is not as good as the previous photos. So yes, our program may be not that accurate because it hasn't been trained enough, but it will at the end say that the photo that it is not Trump is the Hillary one because it has the lowest probability on the Trump label.
Well, that is it. That is our program. We hope you enjoyed the video, and thank you very much for watching.
Thank you.
Okay, so just for your guys' enjoyment, and maybe if you were wondering why our other files were called Trump 4 through 5, we actually ran this test before this video on this set of data using the same Hillary photo and these 3 Trump photos. And at first we didn't think our program was running correctly because it actually said that the one that is not a Trump is Trump. So then we peeked a little bit into the pictures and we kind of saw why this was happening.
So the Trump 2 is not a Trump because of this. So yeah, I mean, like,
it seems that this picture is so different from the training data that it actually thinks that Hillary Clinton, it looks more like Trump than this picture looks like Trump. You can see that the probability doesn't go down that much, but it's still, I mean, lower than Hillary Clinton's.
So yeah, think about it again. Our program needs more training so that it can recognize more. And that's one of the pitfalls that we have found. Thank you.
And goodbye.